Okay, thank you very much for the introduction. Thank you also to FGR, Russell, for the invitation here. I've also just been informed I need to shorten my presentation by 5 minutes on the fly to make up some time. We're starting just a little bit late, so I will move through this a little bit more quickly than I had planned. But yeah, harvesting technology and automation trends. For those of you who know Hunter Harrell, a colleague of mine down at the School of Forestry there, we do a lot of our work together, and he is one of the primary people who works on the FGR funded research work within our team there. Just in terms of the presentation overview, we'll spend a little bit of time talking about robots. Robots are coming, obviously, but really the near future is really about autonomous forestry machines, and I'll give you some highlights in there. Then I'll step through some of the trends that we'd like to talk about. Specifically, we've just completed a hauler survey or a yarder survey. We did one back in 2012, just completed one 2018, so we can really start to see some of these technology trends within our equipment and how we're using that equipment. Warwick mentioned the benchmarking database. It's something that helps us track cost and productivity of our systems. And then in terms of technology, I'll show you a couple of examples of technology that we've been directly involved with at UC as part of the FGR program. And one of the highlights there is that we've been able to extend our research work into logging crews. So we actually teach a lot of professional development workshops, which is really great, getting results where it really matters. Finally, I'll finish off a little bit about the integrated biomass harvesting work that we're dealing with. See a robot there. You may have seen that video clip before, but why don't we have robots working in our forest industry? The forestry environment is a very difficult environment. Most robotic systems work in very managed, controlled environments such as factories. There's a lot of really cool drawings out there. You see that top left picture, really futuristic looking harvesting machine, something that might float or drive through the forest, knocking trees over. The reality is there's a lot of low-hanging fruit out there in terms of autonomous machines, really cool ideas with robotics, but some of them are still some distance off. Some of the examples that we do have in forestry already is semi-autonomous. So semi-autonomous refers to basically a computer controlling a whole aspect of an operation. And the one I'm going to demonstrate here, it's been operating probably close to 15, 20 years now in Europe on their yarder systems, is that the whole carriage movement already there is being controlled by a computer, and that has some very specific advantages in that, first of all, most obvious one, there's no operator, or the person who's looking after the yarder is available to do some other work. Okay, and here we see this video. So you see the breaker out, so the choker setter standing there. At this point, basically, the computer takes over the control of the machine. You see these gentlemen there have got their hands off the controls. That tree is simply going up to the landing all by itself. So the computer is controlling this whole winch system. You see an operator in the background, but they're actually processing. So you've got a one-person job where we would typically take 2 or 3 people. One of the specific advantages of having a computer-controlled winch system here is that, for example, if a tree gets hung up, if it gets hung up behind a stump, we have these big spikes and tensions. It takes an operator about 1.5 to 2 seconds to respond to that. The computer can respond in 1/1000th of a second to that and actually stop it. We're tipping over about 1 yarder here in New Zealand every month. That's the stats on our yarder tip overs. So that's one of the ways that the technology can help us prevent these particular accidents from happening. The reason I left this slide up here, Keith will present a little bit later on. One of the focus areas of the new FGR program is to have more automated systems working in a smaller space, and that's a really nice example of a hauler system working on a very small space, in this case roadside. The other thing that we'll see in this picture here is you can see the biomass issue highlighted by Kit in his presentation yesterday, and you can see here how some of the European systems are managing it as a separate product. They're able to store it and they will pick it up as part of their regular harvesting operation. Here's another one that's getting a little bit closer to home. Obviously, a lot of our extraction is done by ground-based systems, our skidders and forwarders. Here is a specific system that's been designed for steep terrain. So we've got a winch assist harvester working on the slope. So that's actually being supported by a cable. And you've got this thing, and they actually call it a pulley, but it's a little buggy that simply shuttles itself up and down between the harvester and the roadside. So it's an unmanned extraction system that's bumping up. The harvester loads it directly, then it shoots itself down and ends up at that roadside to be unloaded by an operator that then also turns around and loads the trucks. So can we expand it? This one works on a rope, and the reason why it works on a rope is because in Europe it's not clear foul, they're working under canopy, so they're restricted in terms of the GPS signals that they can get, so they have to work along a rope. In New Zealand, of course, we're working in clear foul, so we can actually work more extensively with GPS. We wouldn't be the first industry to really adopt sort of autonomous extraction systems. Both mining as well as farming have are quite far advanced in adopting this technology. Here, by example, we've got a tractor drone. And it's very simple technology. It's simply your GPS unit on top, and then you may have some sensors or video cameras on the front to help for that final control. But in this case, they're harvesting grain or corn in this case. But this machine here, this tractor here, is simply a drone. It's what they call a tractor drone. It doesn't have an operator, and it simply shuttles between the unloading area. You've got a GPS on the harvester, it knows where to go, it'll chase it down the paddock, and when it gets right next to it, it'll follow it along until it's full, and then it shoots back to the unloading area. So you can easily imagine that our skidders and forwarders would be able to do a very similar operation without an operator in it. The exciting thing, and I should say some of this work was supported by the Australian Forest Wood Association, Wood Products Association, and one of the reasons there is perhaps also for our manufacturing industry is if you have a look at the tractor unit down below there, what do you see? There's no cab on it. There's really a lot of design opportunities that we can start to implement on our machines if we don't have to have a cab. The typical cab on a harvester or forwarder is $150,000. So if you build a machine without a cab, it's $150,000 cheaper. Okay, so straight away you have a real financial advantage. These little drone tractors, that's currently a $500 million industry. So if we were to lead this development and our manufacturers were able to lead it, we could really capture a big international market share. So that's quite exciting for our industry to be able to work on that. We have got a little lead-off project which is co-funded by FGR as well as FWPA, and that's really starting to build a prototype. So I had a group of students here, and this is the prototype they've come up with. It's about just over a metre long, but it's a little shuttle, and it's got the GPS unit on it. They've designed a control system. It's battery powered. It doesn't look great at the moment, but it is something that moves around, and at least it's a proof of concept. So we can build them, and obviously the smarts on it, the computer technology is the thing that we can transfer. And for us at the university, it isn't so much the machine, but look, you've got 7 young people there with engineering backgrounds. They're going to be out in the industry next year, and they'll be with the people that take this to the next level. So that's the exciting thing for us. Most people get excited more about robots knocking over trees. That is cool, but the reality is our current robotic systems, while they all have cameras, they actually can't see. Okay, they're relatively dumb in terms of what's coming up in their vision system isn't something they can interpret. So here's a picture out of Oregon State. So it's only when we've got very big spacings and clear backgrounds can we actually identify a tree with a video camera system. So the hardware is there, we've got the videos, we don't have the software to identify it. For example, what happens if an object like this pops up? It's also round, it's also brown. Is it a short tree? The harvesting system won't know, okay? So, and where we will be able to step this up to the next level is that when we can get these images and throw them in the cloud. Just like if a word pops up and you don't know what it is, you Google it. What we need is these machines to grab that image and throw it into the cloud, and it'll come back and go, that's an oil drum, don't cut that one. Okay, so that's where we want to be. The other thing that we have with our Anything that has cutting systems is, of course, that risk of somebody's in the forest. What about if somebody's kid standing in the forest and we end up chopping him or her up? That's a social aspect that we need to deal with. If people go and dress up as trees and stand in the forest when we've got these harvesting systems, of course, all bets are off. But these are these issues, the social issues that we have with harvesting systems as opposed to simply autonomous extraction systems. Where vision does come in, though, if we've got relatively well-defined objects, the software can spot them. So, for example, we know our cable logging systems. Most of our cable yarders now have cameras on them, and with these cameras, as we fly over a felled area, it can actually see the trees on the ground because they're well-defined objects, so it can spot them. And if we go towards more automated hauler systems, obviously we can get the carriage to know where the trees are, so we can identify the butt end. We know we want to grab it about 2 meters in from the butt end. This thing will be able to shoot it right down to that. So that's a near future opportunity that we're currently working on. Trends. We've just completed a Yarder survey in 2018. I did one back in 2012. What we can see, we've got about 10% more machines operating in the country. There's a shift, as you might expect, towards the East Coast as well as to the southern North Island in terms of where our machines are going. What is interesting is there's a greater proportion of crews now in woodlots. About 30% of the yarders we've surveyed are working in woodlots. And there's a number of new players that have come in, the TMARs. There's one collar, there's an active, and as of a couple of weeks ago, there's one new South African machine in there as well. With regard, a lot of data on here, but more swingers. We're not referring to the social tendencies of the people who operate them. We're actually referring to swing yarders here. What we see is we're moving away from tower yarders, and we're basically getting more swing yarders in the system as well as more excavators yarders as well. Despite the fact that everybody's complaining about fuel prices, what are we doing? We're still buying the biggest possible machine out there. So what we are finding is as we're replacing our machines, we're still buying bigger machinery. So back in 2012, TMY 70 Medill 071, which are sort of medium-sized tower yarders, were the most common. Now we've got these big swingers, Medill 124, and of course the TMAR 650s have come in as well. They're very large machines that we're working with. In terms of our rigging configurations, and I think this is where one of the biggest jumps has been made, and compliments to the FGR program Keith Raymond leads, is that only 6 years ago, the top 4 extraction systems were all manual, all required breaker outs, choker setters, working out in the forest. We had our North Bend scab, high lead, and now in the 2018 data, 3 of the 4 preferred rigging systems are all mechanized. Okay, grapple, carriage, or motorized carriage type system. So there's been a really, really dramatic move in our adoption of technology. Yarders are moving slowly, but what we're doing with our yarders is moving very, very quickly. We're also involved in a European Union project, so the European Union actually pays us to do some research work, which is always good, but you can see why we might be interested. In Central Europe, there's 15 different yarder manufacturers within a couple of 100 kilometres of each other, okay? So there's a lot of technology being developed, there's a lot of competition down there. So what we're trying to do, or the reason why we're involved, is really try and get some of these smarts that come through the European systems and basically marry that up with the strength that we typically see in our North American systems. So there's been a lot of design and support that we're providing for them to make a market-ready product here for New Zealand. Some of the machines you see here, that's actually Ross Wood. We had a contractor tour that went there just last year. That's actually, both of these systems you see are hybrids. Okay, so they're both electric winch systems, and they both run on about 5 to 6 litres per hour. Okay, the best yarder system we've got in New Zealand is around that 15 to 18 litres per hour is the fuel consumption. So you can see a really big difference, especially in terms of the still the same power output, just a whole lot less fuel consumption. Really quite nice options for our contractors to be working with in the future. Benchmarking. So we've been able to track since 2008, been able to track both costs as well as productivity. So we track costs, that's been increasing slightly. But of course, what's really nice to see is this bump in productivity that we're getting out of our systems, a slow increase on the yarders, a bit of a jump there, certainly for the ground-based systems. We've got some details around that, and one of the big reasons for the jump, of course also driven by safety, is the level of mechanization we see. Okay, so if we just see that blue line there, that's ground-based harvesting systems and the level of processing. One of the questions we can ask ourselves is, how come we never mechanically process the logs that came onto the landing? Over 70% of our crews were still working with chainsaws just 5 or 6 years ago, cutting up logs when we had the technology to cut it up. You can see that's moved very, very quickly into much higher levels of mechanization. You can now see the mechanized processing for haulers is almost 100%. I think out of all the data, there's only one entry last year that wasn't mechanized, so that's a big shift. The other shift that we see, that yellow line there, is mechanized falling in front of our cable logging operations, and you can see that for up till 2013, that was almost nothing. Okay, so now all of a sudden about 30% of our hauler crews have got access to mechanized falling to put the trees down in front of them. So you can see both in terms of productivity as well as safety, that's been a really dramatic and quick shift for our industry. Tension monitoring app, we get the opportunity to work with a number of talented students. So Hunter and I have both done a lot of work on tension monitoring, be it on cable logging systems or on winch assist systems. We use this information extensively for safety, design, testing, as well as our training workshops. But the one person who doesn't get this information is the operator of the machine themselves. Okay, they typically are looking at a single number, and maybe they've got an alarm system on, and guess what nearly all operators do with their alarm system when they've got it in their cab? Turn it off. Why? Because it goes off all the time. Okay, and so on the one hand it should be, well, it's going off all the time, I should be worried about it, but they don't know what to do with that data. So what we've done, a young lady by the name of Amy, she's put that our idea into an app, and that's become commercially available. So now the operators actually have a tablet where they can track their tension, and they can actually see what is happening in specific events. Also, if you were the manager, you could jump in. So Phil Taylor could jump into one of his logging crews, hit a button, and actually see what did they do today? What did they do over the last week? How many overloading events have we had? And certainly if there's a severe overloading event, it's time to replace the rope, because that's how they break after overloading events. Okay, thank you. Another nice project, GPS tracking. We worry about our utilization. We can tell you, again, nice study, is that on these winch assist systems, big powerful systems becoming very popular, but the average utilization of these systems is at 45%, okay? So our contractors are spending a lot of money on winch assist, but we're only using them on average 45% of the time. Okay, so it's a lot of money tied up. So again, it's great. We've got one of our better students there, Ben Rarity, working with PanPack, using that, getting very detailed information by putting a GPS unit on it and actually having an onboard computer that sucks up all this information. So we get a really detailed breakdown and understanding of why, what's the actual delays and what are the reasons for the delays. Is it broken down? Is it waiting for other machines, or is it waiting for the operator? So we get that level of detail to help improve our technology. It's last slide is in terms of the extension. So I talked about these professional development workshops. We get all these cool studies and cool results, and what we've also made the effort to do is to package that up and get that information out to the operator. For example, here's a nice study. This is at a Ryanair site, I believe, but here you can just see different felling patterns and different ways the logs are presented for the operator to extract. And then, of course, we've got the data to back it up. How long does it take to pick up logs when they've been presented in different ways? And we're able to transfer that information to an operator. And Hunter's been spending time with logging crews and basically helping operators understand the impact of load size versus cycle time, as well as understanding that tension, deflection, payload relationship. this is the last one, Harvester Simulator project. So we've got a Harvester Simulator that was donated to us by John Deere. We've had a number of students do their research project on it. We've actually had one comparing operators with gamers, basically people who game regularly. As you can imagine, gamers are actually a lot faster than experienced operators. They just do a lot more damage to the equipment as they go along because they just hit so some of these results are obvious, but the current FGR project, one good way to get students excited, especially male students, is to say, why don't we compare females with males? Go and find a dozen females to come in and actually work on the simulator and compare them with males and just see, aptitude, attitude, because there's actually some really cool research work out of Sweden that show that women, on average, are better operators than men. Can we replicate it? Can we understand why that is, especially around the damage component, okay? So actually I'm just going to skip to the last slide because I appreciate I'm out of time, is that, look, a simple summary for us is that we've been very privileged to be involved with FGR. I think Keith and I counted up just last year, almost had 30 students involved in different aspects of the research projects, which has been great. So the relationship, the partnership has been very beneficial for us, and we thank you and now the levy obviously for the support that we receive to be able to carry out this work. So thank you for your attention.